assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
To write down formula for coordination complexes, we need to follow these steps mentioned here. First, we need to identify the cation or cationic complex and the anion or anionic complex. Then we have to put the cationic complex first and then the anionic complex. And inside the complex, we need to identify the central metal ion first, and we'll have to start with it. And then we have to put the ligands, and if one ligand is present as multiple times, we will have a prefix like tri, di, tri, tetra, or bis, tris, tetrakis. We need to put that in the numerical form as a subscript outside a round bracket and put the ligand inside this bracket. And then we have to put a square bracket outside the whole complex. And finally, we need to calculate the net charge on the complex. And in case of the compounds, we have to make sure that the overall net charge is 0. So let's start with the first problem here. We have hexaaquanickel 2 chloride. So first we have to identify our cationic and anionic part. So hexaaquanickel 2. We know that a complex finishes with the name of the central metal atom or ion. That means we have our complex finished here, and this chloride is our anion here. So we have a cationic complex and an anion. So first we name the cationic complex. We have to start with the central metal atom, which is nickel here. So we write nickel, and then we have 6 water molecule here. We write H2O6, and then since we are finished with naming our complex or writing our complex, so we just put a third bracket outside here, and then we have to put our anion here, which is Cl. Now let's calculate the net charge. Here we have 6H2O. That means that since the water is a neutral ligand or molecule, we have 0 charge for H2O, and the nickel has a +2 charge. That means we need -2 charge on the anion. That means that, and since the chloride ion has -1 or -1 charge, we need 2 chloride ions. So that is our formula for the complex here, NiH2O6 Cl2. Then here we have the name as pentacarbonylchloromanganese 1. So since the name is finished with a central metal atom or ion, so from here we can see that this is only a complex. There is no compound here, or no, we don't have to identify the cationic and anionic complexes. We have only one complex here. So we start by writing the central metal atom or ion, which is manganese. And then we have 5 carbonyl groups here. So put carbonyl in the bracket and put 5 as subscript. And then we have one chloro group, Cl. Now let's calculate the net charge here. So carbonyl is a neutral ligand. It has 0 charge, 0 for carbonyl. For chlorine, we have -1, and for manganese, since it's manganese 1, we have +1. That means the net charge is 0. So the formula here is MnCO5Cl. Now in this case, we have ammonium and then diaquatetrabromovanadate. So let's find out our cationic and anionic part here. So our cationic part here is ammonium, and our anionic part starts from here. So how do you know that this ammonium is not included in the complex. That's because the ammonium is a positively charged ion, NH4 plus. So when you see a positive ion at the beginning of a complex compound name, that means that that is actually the cationic part of the complex that is not included inside the complex. So the name, for writing the name, we start with the NH4 plus. NH4 plus. Oh, I'm sorry, we don't need to put the plus here. And then we start writing our anionic complex. We start with the central metal atom, which is vanadium. We put V, and then we have diaqua, 2 water, H2O2, and then we have tetrabromo, that means 4 bromide, and then we close the bracket. So to make sure that we have a net 0 charge, that for so water is a neutral ligand, we don't have any charge for water here. We have -1 for each bromide, so we have in total -4, and our vanadium here has a charge of +3. That means in total we have -1 charge, and our NH4 plus has a +1 charge. So we can just neutralize this +1 and -1 charge, and we have overall 0 charge here. So then here we have 2 complexes forming the compound here. Here we have our first complex as tris ethylenediamine cobalt 3. As you know that the name of a complex finishes with the central metal atom or ion. This is our first complex, and trioxalatoferrate 3. This is our second complex. So we start with the first complex, or the cationic complex here. So our central metal atom here is cobalt. We start with cobalt, and then we have 3 ethylenediamine. So we write, actually we need to write them together without any space. So if I'm giving any space mistakenly, you have to make sure that you are writing them all together, not with any space. COEN3, and this is our first complex. And then we have, let's start with our second complex. We have iron or ferrous as the central metal atom here, and we have 3 oxalato group or oxalate group, which we write as OX3, and we finish our black. Now we have to make sure that we have overall net charge of 0. So this ethylenediamine it's a neutral ligand, as has no charge, it has 0 charge, and cobalt here is, we have +3 charge on cobalt. And here the oxalato group has a negative charge of -2, so -2 times 3, it has -6 charge, and the iron has +3 charge. So in this complex overall we have -3, and in this complex +3. That means we can just neutralize these two, and we have net charge of 0 here. So this is our formula for the complex here.